Hello, it's dumplet here. Here's an item on algebra. Find the value of f of 2016, given that f is a function satisfying f of x squared plus x plus 2 times f of x squared minus 3x plus 2 is equal to 9x squared minus 15x for all real numbers x. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, we're given with a functional equation, so we should have like a solution, or like a series of steps before we reach the final answer. But since we're asked about the value of f of 2016, one approach might be to assume what f might be. And that's just going to come from a very nice observation in the question. Because, for example, we have f of a quadratic x squared plus x plus 2f of another quadratic x squared minus 3x plus 2. And if I add these two, it's going to equal to 9x squared minus 15, which is a quadratic function. So we can get from this that, well, if I want to find an f of x that works, maybe it can be linear because of the fact that, well, f of a quadratic plus 2 times f of another quadratic, it's going to be a quadratic function. So f of x might be of the form like ax plus b or something. And in fact, I can know what the leading coefficient might be, and it's going to be, in this case, 3. F of x is going to be 3x plus k. Now, the reason being for this 3 is because, let's just say it's a general ax plus b for now, and let's try to compare the coefficients of the x squared term on both sides. So if we compare the x squared term in each of these, f of x squared plus x, it's going to give me an ax squared term, and then the 2f of x squared minus 3x plus 2, this is going to give me a 2ax squared term, and then it's going to be equal to this 9x squared term. Now ax squared and 2ax squared, it's going to give me 3ax squared. So that's how we will get that a might be 3. Again, these are just like assumptions, but if we are able to find a function f that works, then that's going to be pretty nice. Anyway, so that's why I wrote kind of the assumption here that f of x might take something of 3x plus k. Alright, so let's take a look at the next step. Now, how do I get this part? Now, obviously we could have substituted this into the functional equation and tried to solve for k that way via a comparing coefficients, but we can use up a nice trick here, and since we can use up the nice trick here to kind of substitute values of x to remove the unnecessary x values. Because, for example, well, this is true for all real numbers x, so let's just say we substitute x equals 0. Now, if I substitute x equals 0, that's how I get this one. So substituting x as 0, I'll get f of 0 plus 2f of 2 is equal to 0. And now I can use my assumed formula for f of x, so 3x plus k, and substitute f of 0 and f of 2. Now, it's not going to have any x, so I can easily solve for k that way. So for example, f of 0 based from f of x equals 3x plus k, that's just going to become k. And then plus f of 2 becomes 6 plus k. So k times 2 times 6 plus k equals 0. And if I actually solve for k here, I'll get that k equals negative 4. So f of x would be equal to 3x minus 4. So the last step here is just going to substitute x as 2016. Now if I substitute x as 2016, that's going to be 3 times 2016 minus 4. And that's going to give me the answer of 6,044. And that's pretty much the first approach to the question. But this is not really rigorous because we cannot really assume directly that f is a linear function, although it's kind of obvious. But then again, we have to be a little bit rigorous of our proof. But anyways, this is the first approach, and it is a valid approach, and it is a nice trick because we're only asked for a numerical value. So if we can find a value, if we can find a function f of x, in this case we got it to be linear, then no problem at all. But here we're going to continue on with the more rigorous solution of how to get that f of x it's going to be this 3x minus 4. Well, not really, but you're going to see in a moment. So it's a very common technique, but we're going to use somewhat of the trick similar to the system of linear equations. So what do we mean by that? Now, first we have to observe though. We're going to make the following observations. Now, take a look at these two f of quadratics. So f of x squared plus x and f of x squared minus 3x plus 2. Take note that we can factor them as follows. And the next step, maybe not the most obvious thing in the world, but if we substitute the x's in the given equation to negative x plus 1, something nice is going to happen. And this motivation is brought, you're going to see the motivation after I show you what the resulting equation is. So if I make x to be negative x plus 1, again, not an obvious substitution, but in a while you're going to see why. So if I substitute it into the equation, I'll get f of, well, negative x plus 1 times negative x plus 2. In fact, if I expand this out, well, because this is technically x minus 1 times x minus 2, we can bring out the two negative signs. So this is identical to this green term. So this is actually the same thing as x squared minus 3x plus 2. So that's the first term. And the next term, so 2f of, substituting x as negative x plus 1, it's going to give me negative x times negative x minus 1. And if I multiply this out, you're going to realize that this is exactly going to be x squared plus x. And obviously, we have to do it for 9x squared minus 15x. But for now, I'm just going to write it as 9 times negative x plus 1 squared minus 15 negative x plus 1. Now, negative x plus 1 squared, that's just the same as x minus 1. And then I can kind of factor the negative sign here. So it's going to become a plus 15 times x minus 1. Anyways, this is not really the main point. The main point is to kind of see that we've successfully switched the places of x squared plus x and x squared minus 3x plus 2. So we can kind of imagine that this is a system of linear equations. So these are the two system of linear equations. And we are going to solve for the function. Now we can use the simple elimination technique here. So this is very similar to, for example, an equation, a system of equations. Let's just say x plus 2y equals, well, something. Let's just say it's 4 for now. And then, well, this and this and this and this are the same. So the second equation is kind of similar to y plus 2x is another value. Let's just say 6 for now. And this is going to be the technique we're going to use here because it looks like a system of linear equations. It is of that form. So we're going to use similar techniques to help us solve what f of x or f of something is. So, all right, now before we do that though, we're going to expand the 9 times x minus 1 squared plus 15 times x minus 1. So I've expanded the blue one. It's going to be 9x squared minus 18x plus 9. The green one is 15x minus 15. And then combining them, I'll get 9x squared minus 3x minus 6. All right, so now we're going to do the elimination technique. So I propose we're going to do the following. I'm going to multiply this highlighted expression in the asterisk by 2. Now, why do I want to do that? It's because, well, I'll get this 2 times f of x squared minus 3x plus 2 in two equations. And what we're going to do is do like elimination. We're going to subtract this equation. Sorry, we're going to do equation 1 minus equation 2. So we're going to do equation 1 minus equation 2 in the next step. And I'll get the following. So the green ones cancel. And then the 4 times f of x squared minus x minus f of x squared plus x, 4 times f of x squared plus x minus f of x squared plus x gives me the 3 f of x squared plus x. And then 18x squared minus 6x minus 12 minus 9x squared minus 15x. That's just going to give me this one. So 9x squared plus 9x minus 12. Now we can divide both sides by 3 and we're going to get the following. Now, dividing it by 3, it's going to give me 3x squared plus 3x minus 4. But there's a reason why I wrote it intentionally in this form, because the input is simply x squared plus x. So f of x squared plus x is equal to 3 times x squared plus x minus 4. Now, all we have to do is just make sure x squared plus x is 2016, because we want the value of f of 2016, so we can directly make x squared plus x equal 2016, and we're going to get the same thing. Technically, an f of x equals 3x minus 4, based on the assumption we did a while ago, but not really quite the same, because we have an f of x squared plus x, but this is no problem, because we are sure that the roots to this equation, I mean, there is a real root. We can check the discriminant of this one, or we can just kind of observe that, well, I think as x grows large enough, it's going to eventually hit 2016, so there is going to be a value of x that works. In fact, actually, since f of x squared plus x is equal to 3 times x squared plus x minus 4, and, well, x is a real number, so x squared plus x will range across all real numbers as well. Oh wait, no. It's not gonna be across real numbers. Sorry, it's going to be f of x equals 3x plus 4 for some of the values, not all, because x squared plus x doesn't cover all of them. But luckily for us, 2016 is part of the range of this one, so we have no problems here. Anyway, so either we use just the substitute and kind of guess trick in the first part, or we're gonna do solving for one of the two functions via like a similar technique to the system of equations. We're going to get the final answer of 6044. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.